What makes us human? This might be an obvious question, but think about it for a second. Is it the fact that we look alike? Or maybe it's because we form communities? If that's the case, we're no different to apes or ants. Many people believe it's our ability to grow intellectually and learn from each other's experiences that set us apart from other species. So can something be made human? For years, people have been fascinated by this concept. The study of intelligent systems deals with the creation of an artificial intelligence which would instill human adaptability to tackle new problems by implementing in computers the senses and interactivity that make us humans. Our ability to learn and develop from information we already have sets us aside as a species. Machine learning is a subfield of AI, the aim of which is to give computers this ability. Many machine learning examples are inspired by nature. Neural networks, which aim to emulate the way a human brain solves problems, are an interesting model used in areas such as computer vision and speech recognition. Genetic algorithms mimic the process of natural selection by only allowing the most efficient solutions to a problem to survive, so that the best is eventually chosen. These algorithms have applications in, for example, plane routing and stock market predictions. An intelligent computer must also be able to see and understand its surroundings. Computer vision is a heavily researched area in AI. Much like how the brain processes retinal data, a computer needs to be able to comprehend what it sees. Computer vision has an integral application in many areas, including self-driving cars, which have to be able to analyze their surroundings to ensure safety. The approach that is currently most researched mainly involves segmenting the image up into objects and their boundaries, recognition of the bodies by comparing them with already known objects, and reconstruction, which is the creation of a 3D model from the given image. Even more complicated than allowing a computer to see is making it hear and understand what we say to it. This is because our language consists not only from the literal meaning, but also from implied messages. Speech recognition involves a mixture of extremely complex linguistics, mathematics, and computing. It is done through analysing the pitch and letters in the speech, trying to identify patterns and meaning. Speech recognition is of particular importance where typing in commands would be dangerous, which is why it is used in, for example, in-car systems so that the driver can change radio stations easily. Aside from gathering and analysing data, AI should be capable of speaking, which is called natural language generation. One of the ways to do this revolves around initially deciding on the content that will be output, before allowing a sentence generator to split the content into sentences. These sentences are then checked and corrected for their grammar, ready for output by the computer. The generation of standard letters like bank statements, weather reports, and sports reports are a common example of NLG use in real life. If, as time goes by, the current difficulties facing AI, such as the need for funding and increased computational power, are either solved or eliminated, the field will be expected to grow exponentially. If so, it would not be surprising to see major breakthroughs in some of the fields discussed. However, will we ever see a true artificial human? Who will be held responsible for any wrongdoings of AI? What will the new role of people whose jobs have been replaced by robots and AI be? The ethics of further development in this field have been a source of numerous debates. Careful considerations will surely be taken into account so that we as a society can adapt to the ever-changing world with ubiquitous AI.